Welcome to our latest episode of the Lebanese Physicians Podcast, and today we will be discussing building the future of AI in healthcare. And my guest today is Carter Abdullah, who is an engineer at NVIDIA, and he is a developer of a startup called Brev.dev. Carter, welcome to the podcast.
Thanks so much for having me.
Carter, I figured what better to invite somebody who works in AI to tell us more about, I know you don't work in healthcare, but you can tell us more about potentially what startups are out there in the healthcare industry and what we would be looking forward to in the future. So everybody talks about AI. Why do you think most physicians misunderstand? What do you think most physicians misunderstand about today's AI capabilities?
Yeah, I don't know if it's necessarily just physicians, but I'll talk about physicians specifically, but a lot of people don't exactly know where AI is going to be useful in their day-to-day lives or in their careers. And many of them have maybe tried tools 2 years ago, and whether it's a radiologist who's heard of tools that they can use for scans, or it's a clinician who says, hey, I heard that this can sort of take my patient notes, kind of ambiently record it and then log it. And the technology is progressing so fast that if you use this a few years ago and we're like, yeah, it's okay, but it's not better, it actually is more friction to introduce it into my life than not, then I think you're probably actually missing out on the immense amount of progress that we've made over the past 2 years. And I think that probably, I'm an engineer, and I think for us, the sort of thresholds, right? We passed into a new world starting in probably December or so of 2024. And then again in 2025. And now, if you ask any engineer, they'll say that my life is completely different. And so I think that the same is starting to happen in a bunch of different fields. And as far as what physicians may not understand, I'm sure there are many who do, but I would say that please try the latest stuff that your hospital or that your institution is offering you, because there are many tools now, and don't use it like other tools. I think a lot of people are so used to software, and if it doesn't work for them first try, they'll think that either the software is broken or that maybe it's not the right tool for them. Maybe it's a different vendor that they should have had. But in reality, these tools are fundamentally stochastic, probabilistic, and it's a different way of working with technology than we're used to. And I would encourage all clinicians, but also all people writ large in their careers to try and adopt these tools and go a little bit further than just, hey, I tried it once and it didn't work.
Exactly. But one thing I think about all the time is software in healthcare has been out there for a long time. And I think there was some degree of AI for a long time. But what makes the last 2 years very different from previous? It feels like there's a big revolution the past 2 years.
Oh, there's definitely a big revolution. Obviously, fundamentally, I think that it's the transformer architecture LLMs that obviously was introduced with ChatGPT in a consumer product. But we have now gotten to the point where these models are really, really good and can be essentially imbued into different software pieces that make it much more autonomous, I guess would probably be the word I would use, than previous software. So where previously you would use software as a tool, and it would be part of your workflow. You might use something for transcribing your scribble notes, and then use something else to upload it, and then use something else to maybe listen into the conversation for compliance or whatever. Whereas now the AI can actually use a lot of these tools. So you can create much more advanced workflows that do a lot of that. And then it is doing a lot of things that, again, hopefully are the parts of your job that either are less interesting, less exciting, or ultimately just giving you more time to spend time with your patients, which I don't think any clinician would complain about.
Exactly. There's some clients now that help you with that. But I can tell you this year, one of the things I used it for is I was creating the schedule for our clinicians for next year. And instead of spending 5 hours trying to figure out everybody's which weekend they want off, which vacation, I just put them all into one of the AI chatbots, and within 15 minutes I had the schedule out for the next year. It's pretty accurate. So that's one example.
Yeah. And I think that chatbots are just the tip of the iceberg. They're obviously great and you should use them in any way you can. But the long tail of software, it's almost like, it is the iceberg, right? Where the further you go down, there's so much more that can be done once you start to build out those workflows that are not just synchronous. I want this one small thing back, but maybe it's, hey, whenever this trigger happens, I want you to go kick off this entire processes, and small, but again, like the analogy would be like in my work life, I can have it listen into my meetings, but then actually not summarize the meeting, get my action items, and even begin working on the action items that I've had during the call. And so then it just really can speed up so much of what we're able to do. And again, focus on hopefully the things that are the more mentally, cognitively taxing, which sounds bad, but ultimately our jobs are not supposed to be mundane, repetitive tasks, especially if you're working in a field like healthcare.
Exactly. You're giving up on the repetitive tasks and maybe you have more time to spend with your patients. So what tasks do you think physicians should be delegating to AI rather than do themselves?
It's a good question. I think that any kind of task that, again, you can almost have a litmus test of, am I having to think really hard about? Is this something that I do very often in a way that is easily repeatable? And those are those types of things that are really low-hanging fruit to start looking for tools or even building tools out yourself to be able to augment it here. Obviously, some of the most common that now are making their way around the healthcare space are the ones where it's essentially auto transcribing your meetings and even cross-referencing that against what you were supposed to talk to the patient about. So if you're asking, hey, they're on Accutane, and you're asking, hey, have you felt any new depressive episodes, sort of thoughts or whatever? Again, I'm not a clinician, so I'm just coming up with an example that I think is realistic, but it would know that you going into that conversation, that was a question you were supposed to ask, and then can cross-reference against it. And basically you can almost fill out a lot of the sort of low-hanging fruit questions automatically. You don't have to even touch it. Nobody else has to be in the room. And by the time you go out, it's already in your system. Those are the types of tasks that I think are really low-hanging fruit. Other than that, I think that fundamentally, this one's a little bit, maybe that one might have been obvious. This one I think is less obvious, which is these tools, and especially some of the really great startups that are coming out as well, allow you to continue learning the cutting edge of what's happening in your domain in a way that hopefully you can continue learning, obviously far beyond med school, as any doctor should, but be able to do it in a way that you probably would have had to dedicate many times or a lot of time reading, whether it's the recent papers from conferences or whatnot. Now there are obviously tools like open evidence and other technologies to basically say, hey, I can give more contemporary clinical advice and clinical practice with way less time because I have access to all of the basically latest research that's happening in a way that I could voraciously, hopefully, consume it. And again, I'm speaking on behalf of a physician, but I'm not a physician. So I would say that use this as a way to continue to be the most up-to-date information and give your patients the best care that they deserve.
I use open evidence a lot, and I think you just ask it a question and it gives you the answer with a lot of references. So I learn a lot from it, and I think it makes you take care of your patients more up to date and accurately. What specialties do you think will be transformed first by AI? I know you're not a physician, but you may have some insight based on some of the startups that you know about.
Yeah, definitely. It's less so in necessarily like a clinical practice setting, but I think that the areas that I'm super excited about are ones in which, if you think about what LLMs and what AI really does, is it takes a massive amounts of data and then starts to surface sort of patterns from that data and then can make predictions given future data. And for a lot of ways, that's what the entire process of drug discovery or discovering new proteins that might be helpful in different environments is very similar to that process. And so we're already seeing incredible companies, including some of the big ones with obviously the release of models like AlphaFold from Google, but also startups that are now just getting going like Chai Discovery, where I think that there's going to be a whole host of hopefully fields that previously were more for treatment than either prevention or even solutions to certain people who are maybe, it's like there are certain diseases or chronic conditions that I think we just say, hey, the best that we can do for this individual is to manage their quality of life until the end. But I think that the industries that affect the most amount of people, or those diseases that affect the most amount of people obviously are economically incented to be solved. And so my hope is that those practices, whether it's cognitive decline diseases like Alzheimer's, or in the case of, I even think like GLP-1s, the way I've been describing it to people is like, they're a precursor. Imagine once this drug discovery sort of pipeline really speeds up, we're going to have like GLP-1 level sort of discoveries. Imagine if we got a GLP-1 every year for the next 10 years, like in a bunch of different domains. So hopefully a lot of people's industries will change. Other than that, I do think that a lot of people will look at, they'll confuse a job with a task. And it's been over a decade now that people have been discussing radiologists and saying that, oh, radiologists are going to be the first to be impacted. We're not going to need as much radiologists because, of course, machine learning can read imagery very well. But I think that as we've since discovered that the data, again, it's been 10 years and the data has shown that we're actually at a shortage of radiologists. And in reality, the radiologist, if you're able to perform so much more, to analyze many more scans per day, that actually there's no shortage of work for you to do. And actually, again, offloading parts of your sort of work to something that is incredibly fast, can work 24/7 is not a bad thing, right? We have a lot of people, I think, have, and maybe it's like an identity, right? You tie it to your ego, your identity. This is what I do. This is how I help people. But if you really look at it, your job is to help people become better, to help people diagnose problems. It's not to read scans. And so if the machine is reading the scan, you're still very much in that loop.
Exactly. And one example I can think about because I'm a pulmonologist or a lung doctor, is, let's say, lung cancer screening. Like, you do it, you find these lung nodules, but then there's a lot of AI applications now and startups where it will analyze the lung nodules for you and then tell you, do the scan in 3 months, do the scan in 6 months, 1 year. And the other thing I see about it for radiologists, because they're always scared about this, but one of the things I see for them is it reduces their chance of malpractice, because then if you miss something, it might actually point to you and you might be, oh my God, I missed it. Now I'm going to read it. And this could have happened.
Definitely. There's so many people outside of healthcare. And again, I'm outside of healthcare, but I find this stuff fascinating. And I have a twin brother who's actually is studying to become a doctor right now. And people don't realize the level of like false positives or just hit rate on some of even like the most common diseases like breast cancer leaves a lot to be desired, right? No one would say like we don't want more accuracy in pinpointing or accurately diagnosing cancers. And so if machines can do that, yeah, absolutely. I think that's obviously a win for all of us. And that does not mean that the individual who previously was poring over the image of a mole under a microscope is useless. Absolutely not, right? We need them more than ever.
Now I'm going to ask you something that you are very familiar with, which is large language models. Because I guess Brev is developing your own, right? Like, am I mistaken?
It's okay. We basically were helping people train large language models in a way. So we would get people access to the GPUs and set them up in a way that it was ready for people to do whatever machine learning workload they would like to on it.
Exactly. And so how do you think clinicians should think about ChatGPT, Claude, Gemini, and other large language models? And what are the limitations of these models currently in medicine?
Yeah, definitely. I think that these are incredible tools. And I think that something that now people are starting to segment is basically there's the model itself. So actually, when you're using ChatGPT or Claude or Perplexity or Gemini, you're using it in what we call a harness. And it's basically just the system around the model. And so actually when you're typing into ChatGPT, there's the model, but then there's the stuff that remembers your previous conversations and everything around the model that is not just because the model itself just takes in text and starts outputting one token at a time, right? And so there's the frontier models, which are obviously getting incredible. Many of them are closed source. And then there's this new vibrant ecosystem of open source or open weight models that are also coming out, in which case you could put it into any harness you want. So even OpenAI has their model GPT 5.6. You can consume it from an API, which is just like I can build an application around it on my own. I don't have to consume it through ChatGPT. And so all of them can be put into different contexts, but ultimately you can't change the weights of these closed source frontier models. And so as far as limitations are concerned, there are, a lot of people like to, and this is actually great in specific domains of fine tuning, or some people will call it post training, basically altering the weights of a generalized model. So if you think about it like a GPT 5.6, it knows everything from math to some healthcare stuff to World War II history, right? And you implicitly are paying for the knowledge of World War II history when you're consuming it, even though maybe you're only using it for a healthcare related use case. And what you can do with these open weight models is actually, again, post-train or fine-tune the model to be really good, actually exceeding the frontier of a closed source model like a ChatGPT, a Claude, in a specific domain that you care about. And so this is actually exactly how models that are trained to, for example, detect scans or to read radiological scans, how they can basically become really good at doing that better than a human or better than ChatGPT. If you just put a scan into ChatGPT, it would not be as good as some of these models that were specifically trained on this use case. But the same can be true of LLMs. And so you can post-train LLMs to become really good at diagnosing certain things by using all of the data that you might have. And again, this is another constraint on these large language, the frontier closed models, is that things around compliance, right? Compliance and making sure that you're not giving identifiable information of your patients into something that is obviously open and out to the world. Then you basically, and if you have all of this great data that could be used to train a model, again, you can't do that to the frontier models. We're seeing a whole new industry, by the way, not just in healthcare, that is saying, hey, take these open weight models with your data. You can even put it on a GPU. I've got a GPU in front of me here. It's called the DGX Spark. And I can actually post-train models and then run it right here. So even if the internet was off, right? Obviously, we're both Lebanese. It's something that I think a lot about is we were discussing the internet when we joined on, right? Is areas where maybe critical infrastructure is not as reliable. If LLMs become as important to to serving patients as internet does or as electricity does, then what we can do is actually say, hey, we can have this thing running 24/7 with our data. It's right here. It's plugged into a wall. And I think that this is going to be one of the biggest trends that we see moving forward, because we're able to put much smarter intelligence into much smaller footprints. The size of the model is often caused the number of weights, right? So you'll hear the biggest models today are probably somewhere in the 2 to 3 trillion parameter range. But right now I've got one running on my desk in front of me that's 27 billion parameters. So significantly smaller. And yet it exceeds the intelligence of the frontier models from just a few months ago.
Wow. But it exceeds the intelligence of these models in specific topics, right? Or
yeah, it's a good distinction. The model in front of me, it does not exceed the current frontier models in just about anything, but it exceeds the frontier that was just a few months ago. This is how quickly the space is moving. And so it far exceeds, for example, like Opus 4.5, which was released only earlier this year. Right now we have Opus 5 from Anthropic, but the model in front of me that's only 27 billion exceeds Opus 4.5. And the one of the weird things to wrap anybody's head around is obviously the concept of exponentials, and the amount of intelligence we've been able to get out of these models has been holding strong to an exponential for the past 4 years, and I think we'll continue to do so, which means I'll be able to have incredible modern day frontier intelligence without any post-training, any fine-tuning on something that fits on my desk, and probably by the end of this year.
Wow, that is crazy at the speed things are going at. It's a bit scary, but it's very exciting stuff too. But from what you're saying is like large language models are important. They're going forward very quickly. But then if you want to focus on specific topics, whether it's healthcare, law, whatever, you can create your own language models that target these topics, and they would have a lot more knowledge than the large language models on these topics. Saying that now, how much infrastructure you are releasing AI into healthcare? That's one of the things we're talking about, but into other things. But what is the infrastructure behind all of this? This data is stored somewhere, right? And how much infrastructure, how much energy, how much water will this consume? Because that's the thing that people are very worried about, right?
Yeah, it's a good question. I think that I'll address the water first, which is, I think fundamentally there was actually somebody who miscalculated the amount of water consumption of a data center, and they've since corrected the record by not 10x, not 100x, by like 1,000x. If you actually look at the water consumption of data centers, right? I'm not talking about the ones that are sitting on my desk. They do not consume that much water. They use what are called closed loop water systems. They actually, the water itself is actually pretty warm. The GPUs themselves can run pretty hot, not like extremely hot, but pretty hot. And so there's some crazy number, like the amount of energy that water that golf courses consume, or almonds, far exceeds data center. So I understand, again, people should be concerned about any kind of critical resource, whatever, but the water issue is somewhat overblown. On the energy front, I think that what we're seeing is really the build out of the next layer. Again, I described it as infrastructure. And so the majority of now deployments, the majority of, and including even the GPU that I have on my desk, is spent on what's called inference. And so there's the training of the model, which is basically taking all of the data, World War II, math, calculus, physics, etc., and baking it into the model, and that's training it, like going through education as an individual. And then inference is like taking the exam. So when somebody asks you a question, now you're inferencing. Now that's obviously when it becomes actually useful. When a physician is speaking to these things, they're only doing inference. And what the majority of the build out now is dedicated to is inference. And so you need to be able to serve these models, which just means basically having it in a way that can be consumed by the public. And that's where the majority of the build out is happening. But ultimately, the reason why we're building so much is because there is so much demand. And as somebody who would consider myself a power user of these things, I regularly I'm on the top subscription, right? I pay $200 a month on a couple different platforms. And yet I still can basically hit my limit, and it'll be like, hey, you can't do any more because you've used it all up, your allotment. And so it's like the future is one where maybe I want things running all of the time. And if everybody has something running all the time, it's in the early internet. That's what we saw. It used to be like internet consumption. It would be like very spiky, right? And then then the hill would go up a little taller than last time, but then it would go down. It would go up a little taller than last time. It'd go down. But at some point, it becomes just a higher flat line. And I think that we're going to see the same thing in terms of intelligence consumption. And so realistically, if we need more intelligence in the world, then we're going to need more intelligence factories. And that's what these data centers are, which is why we're building them out.
Yeah, that's very interesting. And that brings me to the next question for you, which is, if you have as a physician, you have an AI model you're working with, are you always in the loop, or can the model, if you have it running in the background, can it act autonomously on its own?
Yeah, so that's where the term harness, I think, becomes really important, because I think that, yeah, absolutely. I would love, if you think about how a lot of software engineers work today, especially the people who are really at the cutting edge, I can control it from my phone. And so maybe I'm like walking into a meeting, or I'm about to go to bed, and I basically will kind of send it off and be like, hey, I have this research direction. I want you to go explore it. And you give it obviously more detail than that, but you're dispatching it, not dissimilar to how you would provide a task to a human. Or in the case of, let's say, in software, there's the maintenance of the infrastructure as well, right? You want to make sure that it doesn't go down, that your service is healthy, that if you're going to get DDoS, that you have ways to prevent against it, right? And a lot of people will have these agents that are ready to basically act, again, autonomously in the case where something goes down. And so that then they can obviously try and triage. And the term, sometimes now we're getting all the way to, there's the manufacturing, obviously, in China is very autonomous. And so they have the term lights off factories, where the lights of the factory could be totally off because it's just robots inside building stuff and there's no humans. And so there's a parallel, which is the lights off software factory, where actually it's humans are not even the ones writing or reading the code. It's all agents. So going back to the clinician use case, absolutely. I think that we all, in our personal lives and in our professional lives, are going to have things running nonstop. Now, what they're doing will be, again, up to you. But I think that there's going to it might be you wake up every morning and, again, maybe it goes and searches open evidence for you for the stuff that's in your domain. And you wake up to a text that's, hey, I think this is something you'd find interesting.
Exactly, which might be a good thing, because then you learn something new because it knows what you want and goes with it. It reminded me of something where, like now, let's say with Google Maps or Apple Maps, like let's say every Sunday you go run, let's say somewhere, so it tells you get in the car, it's like, all right, directions too, so it knows like where you want to go.
On that front, I think that, yeah, personal AI is going to be huge, but also this is, again, why, like I keep tapping it, but I wish I could pull it up, but it's all plugged in. The computer that's on my desk that runs a lot of stuff. But there's also the opportunity here, though, for even maybe more privacy than we've had in something that is this fundamental to our lives. Because if it's running locally and it's learning about me, it's understandable that I want some level of sovereignty on that. And so I can have there was the big moment earlier this year of a project called OpenClaw, which was an open source, basically AI agent harness. But I've got one running showing right there that, again, it's the model is on device. It's doing stuff. It manages my calendar. When we set up this, I told it, hey, go add this to my calendar, and it goes and does it. But that concept of a big company learning about me is actually not quite as true, but yet it's still learning about me and is still improving how I like to work with it over time. But I own all the data. I own the models. Weights are not going anywhere.
Exactly. Where do you see the biggest opportunities for healthcare startups over the next couple of years or 5 years?
Yeah, it's a good question. I think we already touched on one, which I think is drug discovery. I think that one is going to be huge and it's already underway. Another one that comes to mind is either like surgical robotics, I think is another area that's going to be super, super cool. I think that we're going to be able to do much, much higher precision sort of surgeries that I think will hopefully mean less invasive long-term effects for a lot of people. I think that the whole realm of, again, personalized healthcare is going to be huge. We're already seeing the biometrics craze, which I know clinicians may have differing opinions on, but whether it's the Apple Watch that people wear or the Oura Ring, or I've gotten 8 Sleep, the continuous glucose monitors, those are all disparate and again, are just giving people a little bit more insight into their life. But again, imagine if you had a lot more time to really, really dig into your patients and could understand a lot more about your patients. I think that we're going to be able to give a level of personalization in healthcare that we've never had before. And I think that family history, all of that. Now, obviously that's brought in, but I think we're going to do it at a level of fidelity we've never seen. So the opportunity to give like very prescriptive, bespoke sort of clinical advice to individual, I think is going to be another huge opportunity.
Exactly. And this goes along with also the medication models and the medication development, because I feel also we're going to have a lot more individualized or medications for cancer. Let's say like you analyze multiple mutations at the same time, you can find a drug for a certain mutation much quicker than in the past.
100%. I think that what I'm super excited about is some of those, again, afflictions that maybe are genetic. They're already, and this is just headlines that I'm seeing, but I think that we've administered actually like a early gene editing, basically solution to babies or something like that, like an individual who is going to have a much shorter lifespan, and it actually worked. Or the case, of course, with the individual with his dog, who I know created a medicine with his dog through chatting with ChatGPT. That was a big news story for a while. But yeah, I think that it would be amazing if we were able to administer literally tailor-made medical solutions to people.
Exactly, with probably less side effects and better efficacy. Imagine we're having this conversation in 2035. What will surprise us most about healthcare?
It's a good question. I think it's not necessarily just healthcare. I think that right now the concept of robotics or AI being like truly, it right now it feels like a tool you reach for, right? But it's not as, you know how it's almost unheard of now that to think of somebody that doesn't have a phone attached to them at all times. I think that there's going to be a similar concept where, as obviously the average age in America continues to grow, and I think that our social services, we have a shortage of doctors, we have a shortage of people in nurses, etc. I think that one of the best places that robotics, especially early, this is already happening, by the way, in East Asian countries. I think it's going to be really normal to see humanoid robots walking around hospitals is similar to humans, shoulder, to help with some of the more 24/7 care for some of our older and sicker. I think that it's going to be, I don't know if it'll be completely normal by 2035 in sort of the general public consciousness, but the problem is so acute that it is going to be a solution that we see.
Yeah, and I can also take it to home healthcare. Let's say you have a patient at home who has a nurse. You can have a skilled robot come in, and because there's a huge deficiency of skilled nurses for home.
That's right.
I'm going to ask you some quick questions now. What's one AI tool you use every day?
Yeah, so the version of ChatGPT on the desktop for coding is called Codex. And what's so great about Codex as well is that in addition to just being an excellent engineer, they have a lot of features. One of them that I've been using more recently is the voice mode. And that means that it's actually bi-directional. So for over a year now, a lot of how I interact with AI is I transcribe. So I'm speaking as I'm speaking to you now. And then, of course, it takes what I said and then puts it as text. And that's great because you don't realize that you actually give a lot more context when you're speaking than when you're typing. And so it's so funny when I look at a lot of people in my own life who are maybe less of super adopters of this technology. And I look at their prompts. And their prompts are so different from my prompts. I speak to it, again, closer to of like how I speak to a human. I ramble, I give it a lot of context, I say, I don't know. Whereas a lot of people I think are used to doing effective Google searches and their prompts look like Google searches, which it's a weird thing to unlearn. But once you do, I think you'll get a lot more out of this tool. But with Codex, it goes one step further and it can talk back to me. And it's just like a stream. And so then it feels, again, much more like a conversation, but I can interrupt it. I can say, no, let's go check out this direction. I can ask if I'm doing multiple things at once. I can say, how's task B going? I mean, oh, let me go check on that. I was like, all right, that's happening. Like, why don't we do something else? Okay, sure. And that's a tool that I've been using every day.
No, that's actually, yeah. And I think exactly with voice, I think also you talk, like you say, because when you're typing, you might actually start like trying not to type everything. When you talk, you say, you relay it's like sending voice messages on WhatsApp, like same thing. What's one overrated AI trend?
Ooh, that's a good question.
None.
No, there's got to be something. I would say, let's come back to that one. I'll think on it while we go to the next ones.
All right. What's one book every AI curious physician should read?
Oh, that's a good question. I think that there's a couple like science fiction books that I think were really interesting. Some of them are a little more dystopian, but still interesting to think about the future where we are, again, much more imbued with technology. Things like Snow Crash come to mind. I don't know if I would recommend that every curious physician should read that one about the AI future. I think honestly the original paper that kicked all of this off was from Google, and it was called Attention is All You Need. And if you have any background in linear algebra, I think that it's magical to look at how simple this concept was and how much it unlocked. And then the scaling laws are another, this was like almost like the way that Sam Altman described it, the co-founder, of course, of OpenAI, is that it seems like these are closer to fundamental laws of the universe, like how we discover gravity. And there's something so magical about the fact that for those who don't know, the scaling laws was a discovery from some early OpenAI people, including Anthropic people, because Anthropic people came out of OpenAI, that as you scale up the amounts of data, the amounts of parameters, and the amount of compute that goes into a model, the model intelligence effectively gets better. Not quite linearly, it's an exponential, but 10x basically more of those axes gets you a 2x increase in intelligence. And that helps to explain as well why the build out is happening and helps to wrap your head around the exponential that is happening, right? Because I think a lot of people will incorrectly, and again, I don't blame people from outside this space, think that nobody knows what's going on. You'll hear this kind of thing of, the people who made this don't even know what's going on. They'll use the term black box. And I just fundamentally disagree with that. It's not some weird consciousness, alien consciousness that we stumbled upon in a box. These are incredible mathematicians and engineers who identified these scaling laws, built it meticulously, and then now are just basically executing along the scaling laws, more compute, more data, so on and so forth. And so I think that if you can understand that trend, then everything else, again, it's still hard to wrap your head around, but it becomes much more tangible, right? And less what is going on. The world's changing under all of our feet. Nobody knows what's going on, which a lot of what I try and do to people in my own life is give a little bit more of that peer behind the curtain, because I think that things become a lot less scary once you start to understand them.
Yeah, because people I would think about it as, oh my God, robots are taking over our lives or something like that, and that's not the case. So what is one healthcare problem you wish AI would solve tomorrow?
Ooh, it's so big, but I really one of my biggest fears, and I know that I think it also does run in my family, is the cognitive deterioration afflictions or diseases like Alzheimer's or dementia. I think that I rarely will bawl my eyes out crying, but ones that always get me are usually somebody, obviously it's terrible at any age, but the sort of people who will record a loved one, whether it's like a wife or something, in like their 50s. And just over the course of a few years, start to obviously forget those who care about them, and that hits me more than anything. And so, if healthcare could make that a thing of the past, I think that would be, if I could fix it. If it could fix it tomorrow, that would be the one to fix.
That's correct, because that's actually one of the diseases that's been resistant, like very hard to treat at this point. I think if a treatment can be found, this would be life changing for a lot of people. Let's go back to this one before we end. if you have an answer to it, one overrated AI trend.
Yeah, I think that the world is changing so fast that even the way that I described how I used to type, now I talk to it, now I talk back and forth to it. I think that a lot of people, any kind of adoption is great, but a lot of people will map either old concepts or stick with the same concepts of how to consume these things for a long time. So the one that I'm getting at right now is some people will call it like prompting guides or prompt templates. There was a moment there where people even thought there would be like prompt engineers. And I think that, again, the world changes. You can speculate all you want, but I think the proof is already in the pudding that we've gone beyond that. You can just talk to it how we're talking right now and get a lot out of it. And any kind of like prompting guide or try these 10 prompts to do whatever is a little bit, in my opinion, just gimmicky. And I would encourage you to talk to it the way that you talk to people in your life. And if anybody tells you that they have these secret prompts to do whatever, I would just call their bluff and say, yeah, that's great. But also there were even people, I think at some point, like selling prompting guides or secret prompts, which to me is just kind of silly.
Yeah, exactly. I mean, and also I feel, you're right, I see a lot of these actually advertisements about prompting guides and stuff like that. But also I think it gets used to you too, because you can prompt it first time, second time. After a month, I feel like it knows who I am. It's like...
That's right.
Yeah.
That's right. And different models are obviously different and they're going to continue to get better. And so that's why it's like there might have been a window for 3 months where it was really important, but that was in like fall of 2024. We're so far past that. Again, it's the best thing that you can do is a little bit every day, obviously stay up to date and challenge what you think it's capable of. Give it a bigger task than you think it's capable of. And oftentimes I think it'll surprise you.
Yeah, I think so. And Carter, thanks a lot for being on the podcast. And now I'm gonna be editing this video using AI.
Amazing. Thank you so much for having me. And hopefully I didn't make any physicians or any people in the medical space angry, but I'm happy to come on as a technologist anytime.
All right. Thanks a lot. Thank you.